Alright, so in this problem, I have 2 to the power of 20 minus 1. So to solve this, I'm going to first start by rewriting 2 to the power of 20 as 2 to the power of 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. Now, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 10 times 2, I can rewrite as 2 to the power of 10 to the power of 2. Now I have this minus 1. Now 1, that's the same thing as 1 squared. So now I have 2 to the power of 10 to the power of 2 minus 1 to the power of 2. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10, and b is equal to 1. So now I have 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. So if you guys already didn't know, 2 to the power of 10, that's equal to 1024. So now I have 1024 plus 1 times 1024 minus 1. 1024 plus 1 is 1025. 1024 minus 1 is 1023. Now I'm going to write this as 1000 plus 25 times 1000 plus 23. Now to solve this, I'm going to distribute 1000 first. So now I have 1000 times 1000, which is 1000 squared, plus 1000 times 23, and I have this, plus now I'm going to distribute 25. 25 times 1000. Finally, plus 25 times 23. Now let's go ahead and simplify this. 1000 squared, that's the same thing as 1 million, plus 1000 times 23, that's 23,000, plus 1000 times 25, that's 25,000, plus 25 times 23, you can do that right here, 25 times 23, 5 times 3 is 15, 3 times 2 is 6, 6 plus 1 is 7, 2 times 5 is 10, carry the 1, 2 times 2 is 4, 4 plus 1 is 5. So if I add these, I get 575. So I have 1 million plus 23,000 plus 25,000, which is 48,000, plus 575, which is 48,575. So if I add these two, I get 1,048,575. So this is my answer. Alright, so in this problem, I have x to the power of x to the power of 5 is equal to 100. So, to solve this, I'm going to first start by taking the power of 5 on both sides. So now I have x to the power of x to the power of 5 to the power of 5 is equal to 100 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m and n, you can change the place of these two, so this is the same thing as a to the power of n times m. Now, if something in the form a to the power of m to the power of n is equal to a to the power of m times n, then a to the power of n times m, this should equal a to the power of n to the power of n. So, in this case, I can rewrite a to the power of m to the power of n as a to the power of n to the power of m. So I have x to the power of x to the power of 5 to the power of 5. And we can think of x to the power of 5 as m and 5 as n. So if I change the place of these two, I get x to the power of 5 to the power of x to the power of 5 is equal to 100 to the power of 5. Now 100, this is the same thing as 10 to the power of 2. So now I have x to the power of 5 to the power of x to the power of 5 is equal to 10 to the power of 2 to the power of 5. Now remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the, sorry, 10 to the power of 2 to the power of 5, that's equal to 10 to the power of 2 times 5, which is 10 to the power of 10. So I have x to the power of 5 to the power of x to the power of 5 is equal to 10 to the power of 10. Now, I'm going to let x to the power of 5 equal to the variable y. So now, if I change the places of x to the power of 5 and y, I get y to the power of y is equal to 10 to the power of 10. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. But this is only if b is greater than or equal to 1. So in this case, I have y to the power of y equals 10 to the power of 10, and 10 is greater than or equal to 1, so this works out, so I can write this in the form a equals b, or y equals 10. Now remember how we set x to the power of 5 equal to y. So now I have x to the power of 5 equals 10. Now I'm going to take the fifth root on both sides. Fifth root of x to the power of 5 is x, so I have x equals fifth root of 10. So this is my answer. Alright, so in this problem, I have 5 to the power of x plus 2 is equal to 4 to the power of x. So to solve this, I'm going to first take the natural log on both sides. So I have ln 5 to the power of x plus 2 is equal to ln 4 to the power of x. Now, if I have something in the form ln a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times ln a. So for ln 5 to the power of x plus 2, I can move x plus 2 to the front. And for ln 4 to the power of x, I can move x to the front. So now I'm going to have x plus 2 times ln 5 is equal to x times ln 4. Now if I distribute the x and the 2, I get x times ln 5 plus 2 times ln 5 is equal to x times ln 4. Now, I'm going to go ahead and subtract 2 ln 5 on both sides. So now I have x times ln 5 is equal to x times ln 4 minus 2 times ln 5. Now if I subtract x times ln 4 on both sides, these two cancel out and I'll be left with x times ln 5 minus x times ln 4 is equal to negative 2 times ln 5. Now if I factor out x from here, I get x times ln 5 minus ln 4 is equal to negative 2 times ln 5. Now, if I have something in the form ln a minus ln b, this is the same thing as ln a over b. So ln 5 minus ln 4, can rewrite that as ln 5 over ln 4, or sorry, ln 5 over 4, which is equal to negative 2 times ln 5. Now negative 2 ln 5, remember how I can move this to the front. So now I'm going to have x times ln 5 over 4 is equal to ln 5 to the power of negative 2, which is the same thing as 1 over 25. So now if I divide both sides by ln 5 over 4, these two cancel out and I'll be left with x is equal to ln 1 over 25 over ln 5 over 4. So this is my answer. Alright, so in this video, I'm going to solve the problem 16 to the power of 3 times 25 to the power of 4. So to solve this, I'm going to first rewrite this as 2 to the power of 4 to the power of 3. And I have this times 5 squared to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this turns into 2 to the power of 12 times 5 to the power of 8. And 2 to the power of 12 is the same thing as 2 to the power of 4 times 2 to the power of 8. Now I have this times 5 to the power of 8. And now because these two have the same exponents, I can multiply those two. So I get 2 times 5 to the power of 8 times 2 to the power of 4, which is equal to 10 to the power of 8 times 2 to the power of 4, which is equal to 16 times 10 to the power of 8, which is equal to 16 with 8 zeros. So my answer is 1,600,000,000.